Good evening, everyone. Today, our group composed of Kazaya Reka Villamayor, Rex Prussia, and yours truly, Cesar Pilarca, will be discussing asphalt for MCM 613 materials and products for construction. So, to give you a flow of our presentation, first, we will have an introduction to our topic. Second, the properties and characteristics of asphalt. Third, the production and construction of asphalt pavement. Fourth, we have the advantages and disadvantages of asphalt. Fifth, the use of recycled and innovative materials in asphalt concrete pavements. Sixth, we have innovation and ongoing research. And lastly, we have the conclusion. So, what are the learning objectives of our presentation? So first, we need to understand the properties and characteristics of asphalt as a paving material, including its durability, flexibility, and resistance to weathering and wear. Second, to discuss the various factors that affect the quality of asphalt pavement, such as the mix design, compaction, and temperature during construction. And lastly, is to introduce the latest technological innovations in asphalt paving, such as warm mix asphalt and recycled pavement, and to explore their potential benefits in terms of cost savings, environmental sustainability, and improved performance. Definition and basic properties of asphalt. It is a mixture of aggregates, binder, and filler, used for constructing and maintaining roads, parking areas, railways, ports, airports, runways, bicycle lanes, and sidewalks. It is composed of hydrogen and carbon with minor proportions of nitrogen, sulfur, and oxygen. In order to bind the aggregates into a cohesive mixture, a binder is used. Most commonly, bitumen is used as a binder, although nowadays a series of bio-based binders are also under development with the aim of minimizing the environmental impact of the roads. Bitumen is a thick black crude oil. Bitumen is a low grade of crude oil which is composed of complex heavy hydrocarbons. In an oil reservoir, bitumen is a thick viscous fluid and must be extracted from the ground. The importance of asphalt in this industry is that it provides the most effective solution. It is also high quality and long lasting. It provides a smooth and quiet ride. It is quicker and easier to maintain. Asphalt pavements are the most recycled material in the world. And lastly, asphalt is the choice for versatility. History of asphalt. On year 625 BC, it is the first ever recorded asphalt road. 500 BC, ancient Greece explores the properties of asphalt. The word asphalt comes from the Greek word asphates, which means to secure. Years later, on year 1595, natural asphalt has been discovered in the New World. In 1824, the first modern asphalt road was recorded. On year 1870, it is a year where America had constructed its first asphalt road. 1907, it is the rise of automobile and refined petroleum asphalt. On year 1956, American Congress passes the Interstate Highway Act. On 1970s, due to energy crisis in America, the Americans were forced to rethink the importance of conserving and recycling, which paved the way of recycled asphalt. And as of year 2005, America has more than 2.5 million miles of asphalt road ever constructed. Next, I'll be taking about the technical properties of asphalt and the types of asphalt mixtures at various temperature. The technical properties of asphalt. First, we have waterproof property. Asphalt is a water-repellent material with a lightweight structure that does not dissolve in water. It also has a strong plasticity, adhesion strength, and band force with mineral materials, making it waterproof. Viscosity. So viscosity, it is a property that indicates how the certain asphalt impede its fluidity. The hardness and density of asphalt are also reflected in its viscosity. Plasticity. So when an external force is applied to the asphalt, it deforms without being broken, and when the external force is removed, the asphalt retains its deformed shape, which is represented by ductility. So the fourth technical property of asphalt is temperature sensitivity. So it is a property where the property of viscosity and plasticity of asphalt change with temperature change. So asphalt is a non-crystal polymer material. So asphalt, on the other hand, has no set melting point and changes shape as the temperature changes. The temperature sensitivity of asphalt is low when the temperature changes at the same rate, but the viscosity and plasticity changes a little. And it is high when the temperature changes at the same rate, but the viscosity and plasticity changes a lot. So lastly, the fifth one, we have the stability of asphalt in the atmosphere. So it is a property of asphalt to resist aging in the comprehensive climate change of heat, sunlight, and atmosphere for a long period of time. Next, we have different types of asphalt pavement in construction. First, we have hot mix asphalt or HMA. Second, we have cold mix. Third, we have warm mix. Fourth, porous asphalt. And fifth, we have the dense graded asphalt. So in a hot mix asphalt pavement, it is used as heat asphalt poured around 150 degrees Celsius. Hot asphalt pavements are popular for their flexibility, weather resistance, impermeability, and resilience. This type of pavement is used in areas where the temperature is above 40 degrees Celsius so that the asphalt mix does not cool quickly. Second, we have the cold mix asphalt. Cold mix asphalt pavements are made using cold mix asphalt, which is used without heating. Cold mix asphalt takes time to cure and harden. As a result of these pavements are soft and have a shorter lifespan. Cold mix asphalt pavements are used in extreme freezing temperatures where hot mix asphalts cannot be applied. It is used as a temporary solution to repair asphalt cracks and potholes until treated by a permanent repair. Third, we have the warm mix asphalt. So warm mix asphalt pavements is produced the same way as hot mix asphalt, except that it is poured at a lower temperature than hot mix asphalt. Binders and additives are added to warm the asphalt mix to perform easy pouring and spreading at a lower temperature. In addition, warm mix asphalt compared to HMA consumes less energy to manufacture and releases fewer fumes. Hence, it is so popular choice in areas with poor air circulation. Warm mix asphalt is resilient and flexible like HMA. It is commonly used for road pavements, driveways, and other commercial and residential pavement construction. Fourth, we have porous asphalt. It is designed to have tiny holes larger enough to let water pass through them. Therefore, these pavements are constructed in areas prone to flooding, water pooling, and etc. This design lets water drain through the asphalt pavement and reach the soil bed. In addition, porous asphalt pavements are hard wearing and durable. Fifth, and the last one, we have the dense graded asphalt. It is a hot mix asphalt that uses densely packed, fine graded, or coarse graded aggregate. It is designed, mixed, and poured to obtain a dense and impermeable pavement layer. Dense graded asphalt pavements shows exceptional performance under all traffic conditions. Here we have a sample video about types of asphalt.
Hello and welcome to Cedar Hill Paving's YouTube channel. I'm Julian and today we're going to be answering one of the most commonly asked questions I get from customers. What type of asphalt do you use? The reason we're devoting a whole video to this question is because it's not a simple answer. There are different types of asphalt for different applications, and depending on your project, we could be using any combination of mixes and thicknesses. We hope that by the end of this video, you'll have a basic understanding of the most common asphalt mixes. The three types of asphalt that we are discussing are HL3, HL3A, and HL8. HL3 is the industry standard material and can be applied in the vast majority of paving applications. This mix can be used in residential areas, walkways, parking lots, loading areas, and more. Chances are, most of the pavement you've traveled across has been HL3 or an HL3 variant. HL3A, also referred to as HL3 Fine, is a special variant of regular HL3 asphalt. What makes it different from HL3 is the increased amount of sand in the mix. This results for a finer surface finish. The mix is commonly used for residential driveways and some asphalt walkways. The last mix we will be discussing is HL8. This specific material has very little sand and is therefore very coarse, but very strong. It would typically be used in heavy-duty applications, such as loading areas, parking lots, roadways, or wherever there is high vehicle traffic, heavy equipment, or large axle vehicles. In these applications, HL8 would be installed underneath a layer of HL3 or HL3A in order to improve the structural integrity and longevity of the asphalt wear surface. Hopefully you found this video helpful. If you'd like to learn more, please visit our channel page for more informative videos. If you'd like to contact us, just follow the link to our website or
Next slide. So to continue, we have the production and construction of asphalt pavement. So we will be discussing how is asphalt produced and what are the layers of asphalt. Then we have asphalt pavement construction, or how is it made, or the step-by-step process in asphalt pavement. Then we will show a video on how or about the quality control for asphalt pavement. So pavement construction and maintenance. So how is asphalt road is produced? So manufacturers create an aggregate mixture in line with specific project requirements, which they are thoroughly wash and dry. Next, they thin the asphalt cement by heating it up, adding a solvent or emulsification in water. Once the manufacturer has heated the aggregate and asphalt cement to the ideal temperature, the manufacturer will mix the two together using industrial mixing machines such as drums or pug mills. The hardest part of the process is getting the temperature right. To do so, manufacturers must take into account the amount of asphalt to be transported, as well as the other factors such as its thickness and compacting. So here we have a picture of the layers of asphalt pavement. So we have at the bottom, we have the subgrade, the formation, the unbound subbase, and the unbound road base, and finally the asphalt layers. The complete 7-step process of asphalt pavement installation. First, we have to demolish and remove. The first step in the asphalt installation process is to remove the existing surface, whether it is asphalt, concrete, or pavers. Step 2, we have the grading and sloping. With a clean state, technology helps asphalt professionals prepare the surface for appropriate water drainage. So, like using laser guided transits and automatic motor graders. And we have the proper water drainage is also vital to asphalt because water is a major cause of damage, including potholes, cracks, and heaving. Step 3, we have the preparation of subbase. So the most important part of asphalt surface is actually the subbase, because the subbase provides a stable surface to support new pavement. The subbase is a frost barrier to help reduce water damage due to freezing and thawing. During the installation, base thickness, base stability, and compaction are essential steps. If the subbase is not appropriately compacted, the asphalt surface on top will not provide years of durability. Step 4, we have proof roll, undercutting, and subbase. So once the subbase is fully graded and compacted, some asphalt company completes an extra step called proof roll to ensure the underlying surface is strong and ready to support new asphalt. So step 5, we have the binder and surface cores. Once the subbase is laid and any soft areas are identified and repaired, it is time to add the binder. So the binder layer is a large aggregate mix with oil, making it very strong and durable. The binder layer can be thought of as the strength of new asphalt surface. Step 6, the installation of new asphalt surface. So once the supportive structures of the new asphalt surface are installed, the top layer of fresh asphalt is added to provide a clean, smooth ride. Step 7, butt joints and transitions. So it is very rare to install an asphalt surface that does not connect to existing driveways, roadways, or parking lots. As such, asphalt pavement constructors must find a way to smooth the transition from old surface to new. To complete the project, we have the final roll. So once the asphalt and butt joints have been laid, the entire surface is smoothened and compacted. Using a roller truck, the new asphalt pavement surface is compacted and smoothed. This process steps ensures that no small bumps of aggregates or stones are left poking through the new smooth surface. In this particular topic, we will show you a video on quality control for asphalt.
Hi, this is Paul Del Rio from Packy. When a paving crew lays down a new asphalt roadway, who is ultimately responsible for that product and its construction? Well, this duty belongs to the quality control or QC technician. They follow the asphalt product, testing for quality and consistency from the stockpile all the way to the finished road surface.
There are many tests used to determine the engineering properties and quality of the asphalt being produced. Quality control technicians working for the contractor play an integral part in ensuring that the asphalt mixture performs well on the roadway. All of the raw ingredients used in the finished roadway must first be tested for quality, and this requires qualified technicians and a certified laboratory. The aggregates and the liquid asphalt, which are essentially the rocks and glue, are often tested well in advance of the actual construction project. Since liquid asphalt acts as the glue holding the mix together, it is essential to determine its properties to ensure that the mix will perform in the field under traffic conditions. The liquid asphalt is stored in large tanks at a terminal facility and is tested on a certain frequency utilizing several sophisticated machines. Technicians can determine how the binder will behave at extreme hot or cold temperatures, its properties after significant aging, stiffness, viscosity, and its ability to recover from loading. The aggregates used in an asphalt mixture are vital to the rut resistance and performance of the surface and must also be tested. Since the stockpiles at the quarry are so large, it is imperative that technicians first obtain a representative sample. Laboratory tests will be performed to determine properties such as angularity, specific gravity, which is the weight of the aggregate compared to the weight of the same volume of water, the presence of elongated pieces, and the strength of the aggregate. Perhaps the most important aggregate test is to determine gradation. Gradation is a description of the different sizes of aggregate present within a sample. Some specifications require blends using all smaller aggregates, whereas other mixtures may utilize a blend of fine, medium, and coarse aggregate. Once the raw ingredients are deemed acceptable, engineers and technicians will develop what is called a mix design. Like a recipe in baking, the mix design determines the proper blend of materials needed to produce the desired asphalt mixture during full-scale production. Technicians will first produce small batches of the mixture in the laboratory and perform a battery of tests. The asphalt material is compacted in a lab machine, producing what is commonly called a pill. The technician will test pills for several engineering properties, including susceptibility to water damage, the amount of liquid asphalt, specific gravity, and the amount of air voids, or space between the rocks, present. With the ingredients checked for quality and a mix design that meets the project specifications, it's time to produce a mix at the asphalt plant. During production, the technician will collect asphalt samples from a loaded dump truck and check the quality of the mixture. It's important to remember that most of the raw materials in the mix are naturally occurring and contain variability. This requires constant monitoring and subsequent adjustments at the asphalt plant where the final mix is produced. Once the truck reaches the job site and is unloaded into the paver, the technician will check the temperature of the mix and perform a visual inspection. Special testing gauges are used during construction to check the density of the mat. After the asphalt is compacted and cooled, cylinders of pavement called cores can be drilled out and examined for thickness, density, and air voids. From the stockpiles to the roadway, a quality control technician is essential for a consistently successful paving operation. Their education and experience make asphalt paving a truly scientific endeavor.
So to present the next topic, we have Engineer Keziah to discuss.
Good evening, everyone. I am Keziah Reka Villamayor, and I will be discussing about the advantages and disadvantages of asphalt as pavement material, the use of recycled and innovative materials in asphalt concrete pavements, and innovations and ongoing research on asphalt. Roads fulfill a crucial function in modern society, providing increased mobility for people, goods, and services. The following are the advantages of asphalt concrete pavement. It's smooth and comfortable, reduces noise pollution, safe, cost-efficient, fast to construct, easy to maintain, flexible, and up to 100% recyclable. Smooth and comfortable. Asphalt is a flexible pavement built in multiple layers with a continuous flow of material moving through the asphalt paver. Thus, it provides the highest level of smoothness when compared to all other pavement types. According to research, an asphalt road produces 50% less noise than a concrete road. This is because of the absence of construction joints and grooves. Moreover, the porous asphalt road further reduces the noise levels by 50%. This can contribute to a better overall driving experience and reduces the stress endured by the driver. The third advantage is it is safe. Asphalt has skid and slip resistance. The variety of asphalt mixtures offers the right solution for all types of road and weather conditions, maximizing safety for all road users. There are mixtures that can be designed to a texture on the asphalt surface and with high skid resistance for areas likely to experience hard braking. The smooth surface of asphalt provides maximum tire contact with the roadway, increasing skid resistance. Fourth is it is cost efficient, and then fifth is it is fast to construct. Laying down asphalt pavements doesn't take a lot of time. This is because of the fact that, unlike concrete, asphalt doesn't require curing time. In most cases, vehicles can travel on these roads almost immediately after the construction is done. This saves a lot of time and money. Sixth advantage is it is easy to maintain. Asphalt roads are very easy to maintain as opposed to concrete roads and other alternatives. Any potholes, cracks, and problems can be immediately addressed and quickly solved. The repaired piece of road meshes smoothly with the original surface. As with construction, the pavement repair doesn't take much time either. The road can be used immediately afterwards. Seventh is it is flexible. Asphalt pavements have high flexural strength. Asphalt is designed to shrink and expand, so it is less impacted by extreme pressure, temperature, or surface movement. Eighth is it is up to 100% reusable. Asphalt is America's #1 recycled product. Reclaimed asphalt pavement contains a lot of bitumen, and reheating and reusing it is simple. Next is the disadvantages. First is the consistent maintenance needed. Asphalt paved surfaces tend to require more maintenance than concrete. For example, seal coating should be performed every 3 years. Second is its lifespan. It doesn't also quite last as long as concrete. Asphalt is a softer material, leading it to deteriorate faster. Reaction to climate. Asphalt pavement tends to soften in extreme heat and become oily. It softens in the hot sun and can stick to shoes, clothing, and car tires. Asphalt pavement isn't the most durable when it comes to certain weather conditions, specifically extreme heat. Its composition can work against it. During these temperatures, it tends to cause cracking, potholes, and raveling. Environmental effects. When reclaimed asphalt pavement is reused or deposited in stockpiles, metals and polycyclic aromatic hydrocarbons, or PAHs, of it can be released by runoff waters, which may end up in surface water and freshwater systems, groundwater, and soils. In our current society, due to environmental and economic concerns, merely creating new asphalt roads is not just good enough. Recycled materials can be used as aggregate or binder in the asphalt mix, and different materials are better at being one rather than another. In this part of my report, I will be discussing the different types of recycled materials and how they can be used. First is reclaimed asphalt pavements. Recycled asphalt pavements is the reclaimed and reprocessed pavement material containing asphalt and aggregate. RAP contains aggregates and aged binder. Engineers choose to use RAP in projects because of the environmental benefits, the price, the other factors such as strength. Along with the strength, RAP has lower specific gravity and lower water absorption than other aggregates. Next is plastic wastes. One of the most commonly recycled materials in our society is plastic. Polyethylene terephthalate, or PET, is the most common member of its plastic family and can be found in clothing, linens, and most plastic bottles. An experiment conducted by Badejo showed that 1% of shredded PET modified asphalt was found to be useful for pavement construction and reduces the quantity of plastic waste in our environment. Third is the use of rubber tires. Another commonly used material in pavements is used rubber tires. These tires can come from cars, trucks, trailers, and many other venues as well. To be used in pavements, recycled rubber tires are mixed with asphalt binders to produce an asphalt rubber pavement mixture. Due to the porous nature, recycled rubber tire pavement is being used to decrease the amount of runoff water and also to improve the control stormwater quality and quantity. Also, due to rubber nature, It has compressive strength of about 20.68 megapascals. Fourth is recycled shingles. Along with the problem with trying to dispose the used shingles, and with a recent spike in asphalt and cement prices, there is an increasing pressure to find such acceptable recycled supplements to virgin materials. To combat this, researchers are using asphalt shingles in hot mix asphalt pavements more and more as an aggregate. RAS in pavement makes the maximum compressive strength of 90 megapascals. Fifth is the use of used motor oil. Since RAP has been exposed to years of ultraviolet degradation and environmental weathering, the material has aged and cannot be used as direct substitute for aggregate and binder in new asphalt pavements. Used waste engine oil has potential to be one of those materials used to restore the old binder. In Deden's report, they concluded that the use of motor oil is a feasible option for binder replacements in recycled asphalt pavements. Waste engine oil can also soften asphalt pavements without having a detrimental effect in the moisture susceptibility. The used motor oil gives the asphalt an average compressive strength of 22 megapascals. For innovations and ongoing research on asphalt, first we have bioasphalt. Perhaps the newest breakthrough in recycled and renewable pavements, bioasphalt is an asphalt alternative made from non-petroleum-based renewable resources. The benefits of using alternative binders are that they can help save natural resources and reduce energy consumption while maintaining, and in some cases improving, pavement performance. Overall, the compressive strength of bioasphalt could be compared to that of regular asphalt. However, there are many other benefits to using bioasphalt rather than regular, like the economic and environmental impacts. Next, we have porous asphalt. Porous asphalt pavements are constructed in the form of underlying open-graded stone bed that provides drainage for the water. As the storm water drains through the porous asphalt and into the stone bed, it slowly infiltrates into the soil. However, the stone bed size and depth must be designed so that the water level never rises into the asphalt. These stone bed, often 18 to 36 inches in depth, provides a subbase for the asphalt paving. While slightly coarser than standard asphalt, porous asphalt pavements are acceptable. Moreover, the porous asphalt pavement does not require proprietary ingredients and does not require special paving equipment. Because of the open structure of the pavement, porous asphalt offers a means to replenish water tables and aquifers rather than forcing rainfall into storm sewers. Porous asphalt also helps to reduce demands on stormwater sewer systems. Next is self-healing asphalt. Self-healing technology is a new field within materials technology. It represents a revolution in materials engineering and is changing the way that materials behave. Incorporating self-healing technology into the road design process has the potential to transform road construction and maintenance process by increasing the lifespan of roads and eliminating the need for road maintenance. Self-healing asphalt using induction heating. Induction heating has regained popularity in asphalt pavement research for improving self-healing in asphalt pavements. Electrically conductive fibers and fillers, for example, carbon fibers, graphite, steel fibers, steel wool, and the conductive polymer polyvinyl were added into the study of electrical conductivity in asphalt pavement. Results showed that electrical resistivity significantly varied with the type, shape, and size of fibers and fillers. This research was conducted by Wu and Company. Next, another self-healing asphalt is by using bio-based spore microcapsules like cooking oil and sunflower oil. Asphalt pavements and bituminous composites are majorly damaged by bitumen, aging, and fatigue cracking by traffic load. To add, maintenance and reparation of asphalt pavements is expensive and also releases significant amounts of greenhouse gases. These issues can be mitigated by promoting asphalt self-healing mechanisms with encapsulated rejuvenators. The ability of the required microcapsules to be resilient against high temperature, oxidation, and mechanical stress is essential to promote such self-healing behavior without compromising the field performance of asphalt pavement. That's all for my report, and the next reporter is Engineer Rex.